Let's read the question number 4. Question number 4. Given that m, phi, and n are first three terms of geometric progression expressed in terms of n, the first term, and the common ratio of the progression. Whenever you see geometric progression, you always write this one is first three term, right? You take the T2, this is a T1, this is a T2, right? This is a T3, right? The concept of GP is T2 over T1 equal to T3 over T2. So based on that, we will just write phi over m is equal to n over 5. Alright, then we will just cross multiply. Hence, m times n equal to 25. Right, then the question asks, the question asking express in terms of n, the first term and the common ratio of the progression. So we want the first term, which is m. This is the first term. In terms of n, meaning what? Meaning that we don't want to write m. We want to write m as something to do with n. That is called in terms. In term means that we want to express m something to do with the n, but it can be a half number. Okay, so this is first term, which is m. Our first term. This is our first term, isn't it? Okay, then the question also want common ratio. What is our common ratio? Common ratio of the progression in terms of n, highlight again, in terms of n. Common ratio, that means we have to write common ratio is T2 over T1. Where's the T2? The T2 is 5. 5 over m, and we already got the m here. 25 over n, right? So we substitute inside here. It becomes, I think you better write 5 divided by m. 5 divided by m. Then you substitute 5 divided by 25 over n. And then you make it multiply n over 25. Finally, this is the r, which is n over 5. That is so-called r in terms of n, right? Okay, let's proceed to the next question. The sum to infinity of the progression. Sum to infinity. What it means by sum to infinity? Meaning that we are going to use this formula. Okay, so the r is obviously less than 1 for this case. So it's okay, we just use a formula. Our a is 25 over n just now. Our r is this one, right? This is our r. Our a is here. This is our a. This is our r. Alright, so we will minus 1 minus r, n over 5. So let's see, we can simplify. This one we write 5 minus n over 5. If you see the fraction very confused, you just convert to dy, meaning that 25 over n divided by 5 minus n over 5. Then we will inverse it, right? That's how we simplify the fraction. It becomes like this. Then you can have the answer. We can't do simplification. We can only multiply this. 5 times 25, 125, n minus 5n. That is how you solve for sum to infinity. Meaning that you just apply the formula. Alright, that's all my sharing on question number 4. Geometric progression and sum to infinity. Normally for sum to infinity, the r must be less than 1. Okay, that's all my sharing on question number 4. Let's proceed to question number 5.